Welcome to a new era where quantum mechanics and artificial intelligence are joining forces. This convergence is set to revolutionize how we solve problems that were once thought impossible. Imagine a world where AI can tackle challenges far beyond its current reach, thanks to the power of quantum computing. In this video, we'll explore how quantum mechanics is poised to supercharge AI, unlocking solutions to problems that have long stumped even the most advanced classical computers. Let's embark on this journey to discover how these two groundbreaking fields are coming together to reshape the future of technology and intelligence. Modern artificial intelligence has achieved remarkable feats, but it's now running up against a formidable barrier, the computational wall. As AI models grow more complex and datasets balloon in size, classical computers struggle to keep up. High dimensionality, intricate patterns, and combinatorial explosions make certain problems nearly impossible to solve with traditional methods. Whether it's navigating vast parameter spaces or detecting subtle correlations, classical AI faces inherent limitations. This scene sets the stage for why a new approach is needed, one that can break through these barriers and open up new possibilities for intelligent systems. Let's dive deeper into the specific challenges that classical AI faces. High dimensionality means navigating enormous parameter spaces, which quickly becomes unmanageable. Intricate patterns in massive datasets can elude even the most sophisticated algorithms, making it hard to extract meaningful insights. When it comes to optimization problems like logistics or drug discovery, the number of possible solutions can grow exponentially, leading to what's known as a combinatorial explosion. These intractable challenges highlight the need for a fundamentally new approach to computation, one that can handle complexity at an entirely different scale. The heart of this revolution is a shift from classical bits to quantum bits or qubits. Classical bits are the foundation of all current computing, existing in one of two definite states, 0 or 1, but quantum bits are fundamentally different. Thanks to the principle of superposition, a qubit can be 0, 1, or any combination of both at the same time. This unique property opens the door to entirely new ways of processing information, allowing quantum computers to tackle problems that are simply out of reach for classical machines. Superposition is what makes qubits so powerful. Unlike a classical bit, which can only be off or on, a qubit can exist in multiple states simultaneously. This means that until a qubit is measured, it represents 0, 1, and both at once. This property is the key to quantum computing's massive parallelism, enabling it to process a vast number of possibilities all at the same time. As we'll see, this capability is what allows quantum computers to tackle problems that would take classical computers an unimaginable amount of time. To appreciate the leap that quantum computing represents, let's quickly revisit classical bits. In a traditional computer, a bit is either off 0 or on 1. Every calculation, every piece of data is ultimately built from these simple binary states. While this approach has powered decades of technological progress, it's fundamentally limited when it comes to handling the complexity and scale of today's most challenging problem. Now contrast that with the quantum bit or qubit. A qubit doesn't just flip between 0 and 1, it can be both at once thanks to superposition. This means a quantum computer can represent and process many possibilities simultaneously, vastly increasing its computational power. This ability to hold multiple states at once is what gives quantum computing its edge, especially for the kinds of complex problems that challenge classical AI. Quantum parallelism is the secret sauce behind quantum computing's extraordinary capabilities. Because a system of qubits can represent many values at once, a quantum computer can explore millions of possible solutions in parallel. Instead of checking one path at a time, it surveys the entire landscape of potential answers simultaneously. This means quantum computers can solve certain problems much faster than even the most powerful classical supercomputer. Quantum parallelism, quantum computers can explore many possibilities at once, drastically speeding up computations for complex AI tasks. This is a game changer for fields that require analyzing massive datasets or solving intricate optimization problems. By leveraging the unique properties of qubits, quantum AI can tackle challenges that would take classical computers years or even centuries to solve. Quantum computers aren't just faster versions of classical machines, they require a whole new class of algorithms. This is where quantum machine learning or QML comes in. QML algorithms are specifically designed to harness the power of quantum mechanics, enabling new ways to train models, optimize solutions, and detect patterns. These algorithms are at the forefront of the quantum AI revolution, opening up possibilities that were previously out of reach. One of the key benefits of quantum machine learning is accelerated training. Quantum algorithms can process complex models and massive datasets much more efficiently than classical methods. This means AI models can be trained faster, allowing researchers and businesses to iterate and innovate at an unprecedented pace. Faster training times open the door to more sophisticated and capable AI systems. Quantum algorithms excel at optimization, which is crucial for many AI applications. Whether it's finding the best route for delivery trucks or optimizing a financial portfolio, quantum computers can sift through massive numbers of possibilities to find the optimal solution quickly. This is especially valuable for problems where the number of variables is so large that classical computers simply can't keep up. Another major advantage of quantum-powered AI is its ability to detect patterns and anomalies that classical algorithms might miss. By leveraging quantum mechanics, these systems can analyze high-dimensional data and uncover subtle correlations. This leads to more accurate predictions, better anomaly detection, and deeper insights across a wide range of applications. The combination of quantum computing and AI is already beginning to unlock new capabilities across multiple domains. From faster model training to advanced pattern recognition, quantum-powered AI is making a tangible difference. In the next few scenes, we'll explore 4 key areas where this synergy is having the greatest impact: accelerated intelligence, enhanced perception, next-generation autonomy, and novel AI architectures. First, let's look at accelerated intelligence. Quantum AI enables faster model training and superior optimization, allowing intelligent systems to learn and adapt more quickly. This means AI can tackle more complex tasks, make better decisions, and deliver results in a fraction of the time required by classical methods. Accelerated intelligence is transforming industries from logistics to finance, making AI more powerful and efficient than ever before. Next, quantum-powered AI brings enhanced perception. By analyzing data in new ways, quantum systems can recognize advanced patterns and detect anomalies that would otherwise go unnoticed. This capability is crucial for applications like fraud detection, network security, and predictive analytics, where spotting subtle differences can make all the difference. Quantum AI is also paving the way for next-generation autonomy. Smarter, faster decision-making is essential for autonomous systems like self-driving cars and drones. By leveraging quantum computing, these systems can process information and react to their environments more quickly and effectively, making them safer and more reliable. Finally, the synergy between quantum computing and AI is enabling the development of entirely new types of AI models. These novel architectures can solve problems and perform tasks that were previously unimaginable, pushing the boundaries of what artificial intelligence can achieve. Let's take a closer look at how quantum AI accelerates intelligence. Quantum parallelism allows for processing vast and complex datasets far more efficiently than classical methods. This dramatically reduces the time needed to train sophisticated AI models, enabling faster innovation and deployment across industries. Quantum algorithms are uniquely suited to solving complex optimization problems with a massive number of variables. Whether it's route planning in logistics, portfolio optimization in finance, or molecular modeling in drug discovery, quantum AI finds better solutions faster. This capability is already making a real-world impact in industries that rely on optimization. Comparing quantum and classical training methods highlights the advantages of quantum AI. While classical training can be slow and resource-intensive, quantum training leverages parallelism to handle larger datasets and more complex models with ease. This leads to faster results and more powerful AI systems. In logistics, quantum AI is revolutionizing route planning and supply chain optimization. By quickly evaluating countless possible routes and scenarios, quantum-powered systems can find the most efficient solutions, saving time, reducing costs, and improving reliability for businesses worldwide. Finance is another field benefiting from quantum AI. Portfolio optimization, risk analysis, and fraud detection all require processing massive amounts of data and finding optimal solutions. Quantum algorithms excel in these areas, enabling financial institutions to make smarter, faster decisions. Drug discovery is being transformed by quantum AI. Molecular modeling and simulation require analyzing vast numbers of possible compounds and interactions. Quantum computers can process these possibilities in parallel, accelerating the search for new medicines and therapies. Quantum systems excel at analyzing high-dimensional data, making them ideal for advanced pattern recognition. By identifying subtle, intricate patterns and correlations, quantum AI can uncover insights that classical algorithms might miss. This leads to breakthroughs in anomaly detection, clustering, and predictive analytics. With quantum AI, anomaly detection becomes more accurate, helping to identify fraud or network intrusions with greater precision. Clustering algorithms also benefit, grouping complex data points in more meaningful ways. These advances lead to more reliable forecasts and improved decision-making across industries. Predictive analytics is another area where quantum AI shines. By leveraging quantum algorithms, organizations can create more nuanced and reliable forecasts, improving everything from supply chain management to financial planning. The ability to analyze complex data in new ways is transforming how businesses anticipate and respond to change. Quantum-enhanced AI is pushing the boundaries of autonomy. Autonomous systems like self-driving cars and drones rely on real-time decision-making and dynamic route planning. Quantum AI enables these systems to react faster and more optimally to complex environments, making them more capable and adaptable. Quantum machine learning is enabling the development of entirely new AI models, such as quantum-native generative models. These models can tackle immense combinatorial problems that are far beyond the reach of classical AI, opening up new frontiers in artificial intelligence research and application. Quantum AI is not just an incremental improvement, it represents a paradigm shift. By breaking through the limitations of classical computing, quantum AI can address problems with high dimensionality and intricate patterns that were previously intractable. This breakthrough is expanding the horizons of what machines can learn, reason, and create. Quantum AI directly addresses some of the toughest challenges in artificial intelligence. By handling high-dimensional data and detecting intricate patterns, it breaks through barriers that have long limited classical AI. This enables new discoveries and solutions in fields ranging from science to business. With quantum AI, we're unlocking the full potential of artificial intelligence. Machines can now achieve results that were once considered impossible, pushing the boundaries of what's possible in learning, reasoning, and creativity. This is a transformative moment for technology and society. The relationship between quantum computing and AI is truly synergistic. While quantum computing supercharges AI, artificial intelligence is also becoming essential for advancing quantum computing itself. This two-way relationship is accelerating progress in both fields, creating a virtuous cycle of innovation. AI algorithms are playing a crucial role in advancing quantum computing. They help detect and mitigate the noise and instability inherent in today's quantum systems. Machine learning models can optimize the performance and calibration of delicate quantum hardware, making quantum computers more reliable and effective. Maintaining and calibrating quantum hardware is a complex challenge. AI-driven optimization ensures that quantum systems operate at peak performance, reducing errors and increasing stability. This collaboration between AI and quantum technology is essential for realizing the full promise of quantum computing. Looking ahead, the future of technology lies in the collaboration between quantum computing and AI. As these two frontiers merge, they promise to unlock entirely new capabilities, allowing us to solve problems and ask questions we haven't even conceived of yet. This is more than just an evolution, it's the dawn of a new era in computation and discovery. Quantum AI isn't just the next step for artificial intelligence, it's the beginning of a new era. By fusing the strengths of quantum mechanics and machine learning, we're opening up possibilities that were once the stuff of science fiction. The journey is just beginning and the potential is limitless. With quantum AI, we can finally tackle problems that have long been considered unsolvable. From complex scientific research to real-world business challenges, this technology is poised to make breakthroughs that will change our world in profound ways. Fusion of quantum computing and AI is expanding the boundaries of human knowledge. By enabling machines to learn, reason, and create in new ways, we're gaining insights into the universe and ourselves that were previously out of reach. This is a journey of discovery that will shape the future for generations to come. Collaboration between quantum computing and AI is the key to unlocking their full potential. By working together, these technologies can overcome their individual limitations and achieve breakthroughs that neither could accomplish alone. This spirit of collaboration will drive innovation for years to come. We are standing at the threshold of a new era of discovery. Quantum AI is not just about faster computers or smarter algorithms, it's about fundamentally changing how we approach problems and find solutions. The possibilities are as vast as our imagination. The promise of quantum AI is immense. By combining the strengths of quantum mechanics and artificial intelligence, we're poised to solve problems, create new technologies, and unlock opportunities that were once beyond our reach. The journey is just beginning and the future is bright. As quantum AI matures, its impact will be felt in everyday life. From healthcare and transportation to finance and entertainment, quantum-powered AI will make our world smarter, safer, and more efficient. The benefits will touch every aspect of society. To fully realize the potential of quantum AI, we must prepare for the future. This means investing in research, education, and collaboration across disciplines. By building a strong foundation today, we can ensure that quantum AI delivers on its promise for generations to come. In conclusion, the convergence of quantum computing and artificial intelligence marks the beginning of a new technological revolution. By harnessing the unique strengths of both fields, we're opening up a world of possibilities that will transform how we live, work, and understand the universe. The quantum AI revolution is here, and its impact will be felt for decades to come.